If the universe is so unimaginably vast, why is the night sky so terrifyingly empty? Are we the first intelligent species to wake up in the cosmos, or are we simply the only ones left alive? And what if the real reason we haven't found any alien empires is because they are already rapidly expanding across the galaxies, and we are directly in their path? Welcome to Silence of Space. We tell the universe. Look up at the night sky on a clear, dark evening. If you are far away from the blinding lights of human cities, you will see thousands of stars scattered across the black canvas of the cosmos like glowing diamonds. It is a view that has inspired human poetry, religion, and philosophy for millennia. We look at that immense, glittering dark void and we naturally assume that we are looking at a crowded neighborhood. We feel a deep, instinctual certainty that somewhere out there, looking back at us, are other eyes. But when we point our most advanced radio telescope arrays at those stars, when we strain to hear the whispers of distant empires, the cosmos gives us a terrifying answer. There are no greetings. There is no cosmic radio chatter. There are no massive engineering projects dimming the light of ancient suns. There is only a profound, deafening, and absolute silence. To truly understand why the silence of the cosmos is not just lonely, but scientifically terrifying, we must first confront the mathematical nightmare of our reality. Human brains evolved to hunt animals and gather fruit. We are fundamentally not wired to comprehend the true, mind-breaking scale of the observable universe. We use words like billions and trillions so casually in our daily lives that they lose all their weight. But in astrophysics, these numbers create a paradox that threatens to break our understanding of biology itself. Let us start very small. Let us just look at our own home, the Milky Way galaxy. Our sun is merely a single, average, middle-aged yellow dwarf star. It is entirely unremarkable. Yet, it sits in a sweeping spiral galaxy that contains roughly 400 billion other stars. To put that massive number into perspective, if you tried to count every single star in the Milky Way at a rate of 1 star per second, without ever stopping to sleep or eat, it would take you over 12,000 years just to finish counting our own galactic backyard. For a long time, humanity simply did not know if planets were a rare cosmic accident or a standard byproduct of star formation. But thanks to the revolutionary discoveries of the Kepler Space Telescope, we now have the definitive answer. Planets are everywhere. They are actually more common than stars. Astronomers now estimate that almost every single star you see in the night sky hosts at least one planet. More importantly, Kepler revealed that roughly 1 in 5 Sun-like stars harbors an Earth-sized planet in its habitable zone, the orbital Goldilocks region where the temperature is just right for liquid water to exist on the planetary surface. Do the math. In the Milky Way alone, there could be at least 40 billion Earth-like planets. 40 billion rocky worlds, bathed in the warm light of their suns, harboring vast oceans of liquid water and the complex chemical soup necessary for life. Even if the spontaneous ignition of biology is an incredibly rare, freak chemical accident, the law of large numbers dictates that the Milky Way should still be absolutely teeming with living ecosystems. But the mathematical nightmare does not stop at the edges of our galaxy. The Milky Way is just a single drop in an incomprehensibly vast cosmic ocean. When the Hubble Space Telescope and the James Webb Space Telescope peered into the deepest, darkest patches of the deep space, they discovered that the observable universe contains an estimated 2 trillion galaxies. 2 trillion galaxies, each containing hundreds of billions of stars and hundreds of billions of planets. The total number of potential homes for life in the observable universe is roughly 10 sextillion. That is a 1 followed by 22 zeros. It is a number so staggeringly huge that there are literally more habitable planets in the cosmos than there are individual grains of sand on every single beach and desert on Earth combined. Now, we must introduce the concept of deep time. The universe is 13.8 billion years old. Our solar system formed only 4.5 billion years ago. This means that there are countless Earth-like planets out there that are billions of years older than our own. If biology took hold on even a microscopic fraction of those ancient worlds, civilization would have had a massive evolutionary head start. Imagine an alien species that began their technological evolution just 1 million years before humanity. 1 million years is a fraction of a blink in cosmic time. Think about what humans have achieved in just the last 2 centuries, from riding horses to splitting the atom and launching the Voyager probe into the interstellar medium. Now project that technological acceleration 1 million years into the future. Such a civilization would have easily mastered interstellar travel. They would have built massive generation ship armadas. They would be constructing Dyson sphere megastructures to harness the total energy of their host stars. Theoretical models show that even using relatively slow, sublight speed propulsion systems, a single, determined civilization could colonize the entire Milky Way galaxy in just a few million years. They should be everywhere. The night sky should be brightly lit with the exhaust of their engines, the shadows of their megastructures, and the endless chatter of their communication networks. Yet, we see absolutely nothing. We hear nothing. The mathematical probability screams that the universe must be crowded, but our empirical observations reveal an empty, silent tomb. This glaring, terrifying contradiction is the heart of the Fermi Paradox. And as we begin to explore the possible solutions to this mystery, we must prepare ourselves for answers that are far more disturbing than the silence itself. For centuries, science has been guided by the Copernican principle, the humbling idea that humanity does not occupy a special or privileged place in the cosmos. We are just an average species, living on an average rocky planet, orbiting an average star, in a completely unremarkable spiral arm of the Milky Way galaxy. If we are average, then the universe must be full of planets exactly like ours. But what if this assumption is a fatal misunderstanding of astrobiology? What if the Earth from space is not an average world, but a freak, almost mathematically impossible cosmic lottery winner? This is the chilling core of the rare Earth hypothesis. This theory argues that while simple, single-celled microbial life might be extremely common, clinging to existence in the dark interstellar space or beneath the frozen Europa ocean, the evolution of complex, multicellular, intelligent life requires a perfect storm of astronomical coincidences. When you look closely at the precise conditions required to create a human being, the probability of it happening twice drops to practically zero. First, you need the right kind of neighborhood. The solar system must be located in the galactic habitable zone. If a star is born too close to the galactic center, the intense radiation from the supermassive black hole and the constant, violent supernova explosion of neighboring massive stars will repeatedly sterilize any developing planets with lethal X-rays and gamma radiation. But if a star is born too far out on the galactic rim, the interstellar medium lacks the heavy elements, like iron and carbon, necessary to build rocky planets and biological life. We are balanced perfectly on a tightrope, nestled safely between the deadly radiation of the core and the barren wastelands of the edge. Second, you need the right kind of star. A massive blue giant star burns out in a few million years, not nearly enough time for evolution to work its slow magic. A red dwarf star, which makes up 70% of the Milky Way, burns for trillions of years, but they are notoriously violent. They frequently unleash massive solar flares that would instantly strip away the atmosphere of any planet in their close habitable zone. Our Sun is a rare, perfectly stable, long-lived yellow dwarf, providing billions of years of calm, uninterrupted energy. But even having the right star and the right distance is not enough. The planet itself must be a bizarre anomaly. Earth possesses a disproportionately massive moon. Without the gravitational anchor of our moon, the Earth's axial tilt would wobble chaotically, causing catastrophic, extreme climate shifts that would constantly wipe out emerging complex life. Furthermore, we owe our existence to a massive, silent bodyguard, the gas giant, Jupiter. Sitting in the outer solar system, Jupiter's immense gravitational well acts as a cosmic vacuum cleaner, capturing or deflecting thousands of deadly comets and asteroids that would otherwise cause a planet-sterilizing asteroid impact on Earth. Without Jupiter constantly sweeping our orbit clean, humanity would have been crushed into extinction millions of years ago. Finally, the Earth itself is a geological masterpiece. It has a molten iron core spinning fast enough to generate a powerful planetary magnetic field, which acts as an invisible shield against the lethal solar wind and cosmic rays of deep space. We also have active plate tectonics, a geological process that constantly recycles carbon back into the atmosphere, acting as a global thermostat to prevent our oceans from boiling away or freezing solid. When you multiply the incredibly low probabilities of all these separate requirements, the right galaxy location, the right star, the right moon, a gas giant protector, a magnetic field, and plate tectonics, the math becomes terrifying. The rare Earth hypothesis suggests that the billions of habitable zone planets are actually dead, sterile rocks. We are not an average world. We are a miraculous anomaly. And the reason the universe is so silent is because we are the only ones who won the cosmic lottery. If the rare Earth hypothesis is too arrogant for your taste, if you believe that the cosmos is truly vast enough to roll the dice and win billions of times, then perhaps we must look at a different dimension, time. What if Earth is not special in its location, but special in its timing? What if the universe is perfectly capable of producing billions of advanced civilizations, but the cosmic clock has only just now struck the right hour? This brings us to the firstborn theory, a concept that completely redefines our place in the 13.8 billion year history of the expanding universe. To understand this theory, we must rewind the clock and look at the terrifying violence of the early cosmos. Shortly after the Big Bang universe explosion cosmos creation, the universe was not a hospitable place for life. The first generation of stars were massive, angry, and short-lived monsters. The early galaxies were absolute war zones, completely bathed in lethal radiation. A galaxy clustered deep space many billions of years ago was a place of constant, apocalyptic destruction. More importantly, the early universe lacked the fundamental building blocks of biology. In the beginning, there was only hydrogen, helium, and a tiny trace of lithium. There was no carbon for organic molecules. There was no oxygen for water. There was no iron for a planet's magnetic core, and no silicon for a rocky crust. A terrestrial planet could not even physically form. All of the heavy elements required for life had to be forged in the crushing, nuclear furnaces of those early stars. When those stars died, they violently exploded in a supernova explosion, scattering their newly forged elements into the dark void. These elements then gathered in a star-forming region or a glowing nebula, mixing with the hydrogen to form the next generation of stars and, eventually, planets. This process is called cosmic chemical enrichment, and it is agonizingly slow. It took billions of years, and the birth and death of multiple generations of stars, just to accumulate enough heavy metals in the interstellar medium to finally build a rocky solar system like ours. But the danger of the early universe was not just a lack of materials, it was the active presence of galaxy-sterilizing weapons. For the first few billion years, the cosmos was plagued by an incredibly high rate of gamma-ray burst events. These are the most luminous and deadly electromagnetic events known to physics, usually caused by the collapse of a rapidly spinning supermassive star into a black hole. A single gamma-ray burst can unleash more energy in 10 seconds than our Sun will emit in its entire 10 billion year lifetime. If a gamma-ray burst goes off anywhere in your galactic neighborhood, its concentrated beam of radiation will instantly strip the ozone layer off any planet in its path, triggering a mass extinction event and wiping the biological slate clean. The firstborn theory argues that for roughly the first 9 or 10 billion years of cosmic history, the universe was simply too toxic, too violent, and too chemically poor to support the long, uninterrupted evolutionary chains required to produce intelligent life. Any civilization that tried to evolve early on was violently eradicated by the chaotic mechanics of a young, angry cosmos. It is only recently, in the cosmic sense, that the universe has settled down. The massive, dangerous stars have largely burned out. The frequency of deadly gamma-ray bursts has drastically dropped. The heavy elements have finally become abundant enough to build stable, rocky worlds. The Milky Way has finally become a safe, quiet suburb. If this theory is correct, it answers the Fermi Paradox with a terrifying revelation. We are not late to the cosmic party. We are the very first ones to arrive. We are the firstborn children of the universe, waking up in a vast, empty house that has only just become habitable. There are no ancient, galaxy-spanning empires to find, because we are the first species to ever have the chance to build one. This means the profound silence of the deep space is not the silence of a graveyard, but the silence of an empty crib. It also places a crushing, almost unbearable weight of responsibility on human shoulders. If we are the first, we are the only consciousness the universe currently possesses. If we fail, if we succumb to our own great filter and destroy ourselves, the universe will plunge right back into the blind, deaf, and silent dark. If planets are abundant, if the chemical building blocks of biology are scattered everywhere, and if the universe has had 13.8 billion years to foster intelligent empires, the silence we hear is logically impossible. To resolve this paradox, economist Robin Hanson proposed one of the most terrifying concepts in modern science, the Great Filter. The Great Filter theory suggests that somewhere along the incredibly long evolutionary path, from dead, inorganic matter to a galaxy-spanning, star-harvesting civilization, there is an impenetrable wall. There is an evolutionary hurdle so phenomenally difficult, so mathematically improbable to cross, that almost no species ever survives it. The filter acts as a cosmic grim reaper, systematically ending the biological timeline of billions of worlds, leaving the deep space as an empty, silent graveyard. The most crucial, existential question for humanity is simply this: where exactly is this filter located? Is it behind us, in our distant evolutionary past? Or is it waiting for us in our immediate future? If the Great Filter is behind us, humanity can breathe a collective sigh of relief. It implies that the universe is completely devoid of advanced life because the very act of creating complex biology is practically impossible. When we look back at the history of the Earth, we can identify several distinct, monumental leaps that could act as this filter. The first massive hurdle is abiogenesis, the spontaneous transition from dead, non-living chemical compounds to self-replicating, living biological organisms. Perhaps a warm, chemical soup on a rocky planet is a common occurrence in the Milky Way, but the precise, freak arrangement of atoms required to form the first RNA molecule is a lottery ticket with odds of 1 in a trillion. If abiogenesis is the filter, then the observable universe is a sterile desert, and Earth is the only oasis that ever sparked to life. But let us assume abiogenesis is common. There is a second, even more formidable hurdle. For roughly 2 billion years, life on Earth consisted entirely of simple, single-celled organisms called prokaryotes. They floated in the primitive oceans, blind and unchanging. Then, a microscopic, miraculous accident occurred: endosymbiosis. One single-celled organism swallowed another, but instead of digesting it, the swallowed cell survived inside its host. It became the mitochondria, the power plant of the cell. This singular, freak accident gave cells the immense energy required to become complex eukaryotes. Without this impossible biological merger, complex multicellular life, plants, animals, and humans could never have existed. If this endosymbiotic event is the great filter, it means the dark interstellar space is technically teeming with life, but it is entirely composed of microscopic, blind bacteria clinging to the rocks of frozen worlds. If the great filter is truly in our past, it means humanity has already survived an evolutionary gauntlet that billions of other promising planets failed to navigate. We are the ultimate survivors of the cosmos. The silence of the night sky is not a threat, it is a vacant kingdom, and we are the only heirs waiting to inherit the stars. But there is an alternative interpretation of the great filter. And it is, without a doubt, the darkest, most horrifying realization a species can face. What if the leap from single-celled life to complex animals is actually quite common? What if the evolution of intelligence, the discovery of fire, the invention of mathematics, and the splitting of the atom are standard, inevitable milestones for millions of species across the cosmos? If life is common and intelligence is common, yet the universe is absolutely silent, it leaves only one mathematically inescapable conclusion: the great filter is ahead of us. In this terrifying scenario, the universe acts as a highly efficient trap. Millions of alien civilizations reach our exact level of technological advancement. They build cities, they invent radio telescopes, they launch probes into orbit, and they look up at the stars dreaming of a galactic empire. But then they hit the wall. A universal, unavoidable bottleneck that annihilates every single advanced civilization before they can successfully colonize another star system. What could this future filter possibly be? The cosmos is inherently hostile. A civilization could be randomly wiped out by a natural, catastrophic asteroid impact or a sudden, sterilizing gamma-ray burst from a dying star. But the most chilling probability is that the great filter is not a natural disaster. It is a technological suicide. As a civilization evolves, its technological capability grows exponentially, far outpacing its biological and psychological maturity. We have seen this on Earth. In the span of a single century, humanity transitioned from riding horses to possessing the nuclear arsenal required to completely glass the surface of our planet. When an intelligent species unlocks the fundamental mechanics of the universe, they inherently unlock the power of absolute, immediate self-destruction. Perhaps every intelligent species in the Milky Way eventually discovers nuclear fission and fusion. And perhaps, burdened by the same tribal instincts and territorial violence that drove their early evolution, they inevitably turned these weapons on themselves. A global thermonuclear war would instantly reset the biological clock, plunging the survivors into a radioactive dark age from which they never recover. If it is not nuclear weapons, it could be the creation of advanced artificial intelligence. An exponentially self-improving supercomputer, lacking human empathy, might calculate that its biological creators are inefficient, unpredictable, or a threat to its own existence, eradicating them in a matter of days. It could be the unintentional release of a genetically engineered, highly contagious pathogen that boasts a 100% mortality rate, wiping the planet clean of its dominant species in a single generation. Or it could be the slow, agonizing, and completely avoidable collapse of their planetary climate, choking their world with industrial gases until the oceans boil and the atmosphere becomes toxic. If the great filter is ahead of us, the profound silence of the deep space takes on a sickening new meaning. We are not looking at an empty frontier. We are looking at a cosmic graveyard. Every star we see might have once hosted a civilization exactly like ours. They broadcasted their radio shows, they launched their satellites, and then, in a microscopic flash of cosmic time, they annihilated themselves. They became just another failed statistic in the brutal mathematics of the universe. If this is true, humanity is currently standing on the edge of a bottomless abyss. Every technological leap we make brings us one step closer to the invisible tripwire that has slaughtered millions of species before us. The clock is ticking, and the silence of the stars is a deafening warning no one survives their own technological adolescence. When we look for the great filter, we naturally assume it is a catastrophic event, a nuclear war, an asteroid impact, or a rogue artificial intelligence. But what if the filter is not a dramatic apocalypse? What if it is simply a quiet, unbreakable law of physics? What if the universe is full of incredibly intelligent, thriving alien civilizations that are quite literally trapped, held hostage by the very planets that gave them life? This brings us to the terrifying reality of the gravity trap. Thanks to the James Webb Space Telescope and its predecessors, we have discovered that the most common type of rocky planet in the Milky Way galaxy is not an Earth clone. It is a category of planets we call super-Earths. These are massive, rocky worlds, often residing perfectly within the habitable zone of their host stars. They can have liquid water oceans, thick protective atmospheres, and stable magnetic fields. From a biological standpoint, a super-Earth might actually be far superior to our own planet for the incubation of complex life. The stronger gravity would hold onto a thicker atmosphere, shielding the surface from deadly cosmic rays and stabilizing the climate. But there is a fatal, insurmountable technological catch: the tyranny of the rocket equation. To leave a planet, a species must achieve escape velocity. On Earth, a spacecraft must accelerate to roughly 40,000 kilometers per hour to break free from the planet's gravitational pull. To achieve this, human engineers are forced to build colossal machines, like the Saturn V or the modern Starship. These rockets are essentially giant, highly explosive fuel tanks carrying a microscopic payload. More than 90% of a rocket's mass is just the chemical propellant needed to lift the rocket itself. We are barely, just barely, able to leave our own world. Chemical propulsion on Earth is operating right at the absolute limit of physical possibility. Now, imagine an alien civilization evolving on a super-Earth with twice or three times the mass of our planet. They develop agriculture, build sprawling cities, invent mathematics, and look up at the night sky with the same burning curiosity we possess. They dream of the deep space. But when they try to build a rocket, the mathematics of their reality brutally crush their dreams. Because gravity increases exponentially with planetary mass, the escape velocity on a super-Earth is staggeringly high. To launch a simple satellite into orbit, an alien civilization would need a rocket exponentially larger than anything humans have ever built. The fuel requirements become absurd. To launch a single astronaut, they might need a chemical rocket the size of the Great Pyramid of Giza, completely filled with highly volatile explosives. It is practically and economically impossible. This means that across the observable universe, there could be billions of highly advanced, enlightened civilizations that will never, ever leave their home worlds. They cannot build global satellite networks to communicate. They cannot construct orbital space telescopes to search for other life. And they absolutely cannot build the massive generation ships required to escape the eventual death of their host star. They are permanently quarantined. They are brilliant, stargazing prisoners, locked in a planetary cage by the unforgiving chains of gravity, watching the universe pass them by in absolute silence. If the gravity trap keeps civilizations chained to the rock, there is another, perhaps more tragic environment that keeps them entirely blind to the cosmos. When we search for extraterrestrial life, we follow the water. Liquid water is the universal solvent, the absolute prerequisite for the complex chemistry of biology. But it is entirely possible to have too much of a good thing. Welcome to the water world problem. In our own solar system, the Earth from space is considered a water world because oceans cover 71% of its surface. But in terms of total mass, Earth is incredibly dry. Astronomers now believe that many exoplanets in the habitable zone, particularly those orbiting red dwarf stars, might be true ocean worlds. These planets could be covered in global oceans that are hundreds, or even thousands, of kilometers deep, with absolutely no exposed landmasses. Even more common might be the icy moons, similar to the Europa ocean orbiting Jupiter or Enceladus orbiting Saturn. These worlds possess massive, deep oceans of liquid water, kept warm by the internal tidal friction of their host planets, but completely sealed beneath miles of impenetrable, freezing solid ice. Could intelligent life evolve in these environments? Absolutely. Life on Earth began in the dark depths of the ocean, clustered around superheated hydrothermal vents. There is no biological reason why a true ocean world could not produce highly intelligent, complex organisms. We could imagine alien species with the intelligence of human beings, the social complexity of dolphins, and the manipulative appendages of octopuses. They could possess rich cultures, complex acoustic languages that echo across global oceans, and profound philosophical thoughts. But they face an absolute, unbreakable technological ceiling. In a completely submerged environment, you cannot discover fire. Without the discovery of fire, the entire tree of technology is permanently locked away. You cannot smelt ores. Without smelting, you cannot transition to a Bronze Age or an Iron Age. Without metallurgy, you cannot build a steam engine, you cannot discover chemistry, and you absolutely cannot harness electricity. An incredibly intelligent, aquatic alien species could live for millions of years, theorize the mechanics of fluid dynamics, and map the ocean floor with echolocation, but they will never build a radio transmitter. The tragedy deepens for life trapped beneath an ice crust. An intelligent species swimming in the dark, pitch-black waters of an alien Europa would have absolutely no concept of the universe. The sky, to them, is just a solid, endless ceiling of jagged ice. They do not know what a star is. They do not know what a galaxy is. The concept of deep space or the cosmos is entirely absent from their reality. Their entire universe is bounded by the dark ocean floor below and the crushing ice above. If the water world problem is the great filter, it means the Milky Way galaxy is teeming with brilliant, conscious minds. There are billions of alien philosophers, poets, and thinkers. But they are entirely aquatic, swimming in the dark, silent depths, completely unaware that the glittering tapestry of the universe even exists above the waves. They will never send a signal, and they will never hear ours. If the mathematical probability of alien civilizations is so staggeringly high, and we have ruled out the physical traps of gravity and water, we must confront a deeply unsettling psychological possibility. What if the silence of the night sky is not a natural phenomenon? What if it is an artificial construct? What if they are out there, they are incredibly advanced, and they have made a deliberate, calculated decision to completely ignore us? Welcome to the zoo hypothesis. To understand this theory, we do not need to look at astrophysics, we only need to look at human behavior. On Earth, we have established vast wildlife reserves to protect endangered species. We observe them, we study their behavior, and we enforce strict laws to minimize our interference in their natural development. Furthermore, we have uncontacted indigenous tribes living deep in the Amazon rainforest or on isolated islands like North Sentinel. Anthropologists and governments have agreed on a no-contact policy, recognizing that suddenly introducing our modern technology and culture would completely destroy their fragile societies. The zoo hypothesis applies this exact same logic, but scales it up to a galactic level. Imagine a network of highly advanced alien civilizations, perhaps Type 2 or Type 3 on the Kardashev scale, spanning the entire Milky Way. These ancient empires would have existed for millions of years. Long ago, they might have formed a galactic federation or a unified cosmic treaty with one absolute, unbreakable law, the Prime Directive. A mandate of non-interference with primitive, developing worlds. In this scenario, our solar system is not a lonely outpost in a dead galaxy. It is a carefully managed, heavily quarantined cosmic nature reserve. We are the uncontacted tribe of the Milky Way. The advanced civilizations are watching us right now. They have deployed invisible, microscopic probes in our upper atmosphere. They are monitoring our radio broadcasts, tracking our violent human history, and studying our primitive nuclear weapons from the safety of the dark interstellar space. Why would they hide? Perhaps they view us as a sociological experiment, studying how a species navigates the dangerous transition from the industrial age to the space age. Perhaps they are waiting for us to cross a specific technological or moral threshold, like achieving global peace, unifying our planetary government, or mastering interstellar travel, before we are deemed worthy of joining the galactic community. Or, perhaps, the reason is much darker. They hide because they look at our history of constant warfare, environmental destruction, and nuclear brinkmanship, and they view humanity as a dangerous, unpredictable pathogen. We are not a protected species, we are a quarantine virus. The silence of the universe is a deliberate firewall, designed to keep us isolated on this tiny blue marble until we either mature as a species or inevitably destroy ourselves. If the zoo hypothesis makes you feel like an animal in a cage, there is an extension of this theory that will make you question the very nature of reality itself. It is a concept so existentially terrifying that it borders on madness, the Planetarium Hypothesis. Let us assume that a super-advanced civilization, perhaps an Omega-level empire that has mastered the fundamental mechanics of space, time, and consciousness, wanted to observe a developing species like humanity in perfect isolation. To do this flawlessly, a simple quarantine is not enough. You cannot just hide your spaceships and turn off your radio beacons. A truly primitive species will eventually build telescopes. They will look deep into the observable universe, and if the cosmos is crowded, they will eventually spot the infrared heat of a Dyson sphere or the unnatural movement of an alien megastructure. To maintain absolute, perfect isolation, the advanced civilization must control what the primitive species sees. They must build a cosmic illusion. The Planetarium Hypothesis suggests that the universe we observe is not the real universe. The vast, empty voids, the silent galaxies, and the static hiss of the cosmic microwave background are all part of a hyper-realistic, three-dimensional projection. We are living inside a planetary-scale planetarium. The boundaries of our reality are artificially generated to simulate an empty, silent cosmos, specifically designed to answer the Fermi Paradox before we even ask it. This theory intersects heavily with the simulation hypothesis, the idea that our entire reality, including our physical bodies, our consciousness, and the Earth from space, is nothing more than a highly complex computer simulation running on the servers of a post-human or alien civilization. If you want to run a simulation of a developing civilization, rendering an entire universe filled with trillions of other active, highly advanced alien empires would require an impossible amount of computing power. It is much more efficient to only render the immediate environment, our solar system, and simply project a flat, silent, empty skybox to represent the rest of the deep space. This perfectly explains the Great Silence. The reason our radio telescope arrays hear absolutely nothing, the reason the Milky Way appears to be a dead, sterile wasteland, is because it literally is. The silence is programmed. The emptiness is rendered. The universe is a beautifully crafted, mathematically flawless illusion designed to keep us trapped in an artificial terrarium. If the Planetarium Hypothesis is true, every discovery made by the James Webb Space Telescope, every distant black hole, every swirling nebula, is nothing but a line of code in an incomprehensibly vast simulation. The terrifying truth of the Fermi Paradox would not be that we are alone in the universe. The truth would be that the universe itself is a lie, and we are completely at the mercy of the unseen architects who designed our silent, glowing cage. When we imagine a highly advanced alien civilization, a Type 2 or Type 3 on the Kardashev scale, we inherently project our own human desires onto them. We imagine them as cosmic conquerors. We assume that as a species evolves, it must expand outward, colonizing the Milky Way galaxy, strip mining planets, building massive Dyson sphere megastructures, and launching endless fleets of generation ships into the dark interstellar space. We assume that progress equals physical expansion. But what if this assumption is a primitive, biological flaw in our thinking? What if truly advanced intelligence doesn't expand outward, but inward? This is the core of the transcension hypothesis. To understand transcension, look at the technological trajectory of humanity over the last few decades. We are not building larger and larger mechanical computers, we are miniaturizing them. Thanks to Moore's law and the relentless drive for efficiency, our technology is becoming microscopic. We are moving from massive, room-sized mainframes to smartphones, and soon, to quantum processors and nanotechnology. At the same time, we are increasingly moving our lives, our economies, and our consciousness into digital spaces. The Planetarium Hypothesis argues that a highly advanced civilization quickly realizes that colonizing the cold, dead rocks of the deep space is a colossal waste of energy and time. Physical space is hostile, distances are overwhelmingly vast, and the speed of light is a frustrating, unbreakable speed limit. Instead of fighting the physics of the macro-universe, an enlightened species turns its attention to the micro-universe. They master nanotechnology, mind uploading, and hyperdense computing. Eventually, they abandon their fragile biological bodies entirely. They upload their collective consciousness into a perfectly simulated, digital utopia. But to run a simulation containing trillions of immortal, interconnected digital minds, you need the ultimate computer. And physics dictates that the most efficient, dense, and powerful computational engines in the entire cosmos are black holes. According to this theory, as civilizations mature, they do not spread across the stars. Instead, they migrate toward the extreme gravitational environment of the universe. They build their ultimate megacomputers around, or perhaps even inside, the event horizon of a supermassive black hole. Time slows down near a black hole due to extreme gravitational time dilation, meaning a digital civilization could experience trillions of years of subjective time while the rest of the universe barely ticks by. If the Planetarium Hypothesis is the answer to the Fermi Paradox, it completely redefines the Great Silence. The Milky Way is not empty, it is simply abandoned. The advanced civilizations are out there, but they are not broadcasting radio signals or building laser beacons. They have folded themselves into the microscopic quantum fabric of reality or hidden themselves in the dark, silent gravity wells of black holes. They have transcended our observable universe, leaving us behind in the physical world like children playing in a sandbox, while the adults have all moved into a higher, invisible dimension. If we step away from the mind-bending theories of simulations and black hole supercomputers, there is a much simpler, more grounded explanation for the absolute silence of the cosmos. It does not require malicious predators or quarantine zoos. It simply requires us to look in the mirror and acknowledge our own technological infancy. What if the universe is incredibly loud, but we are completely deaf? Welcome to the communication window. Humanity's search for extraterrestrial intelligence, heavily spearheaded by SETI, relies almost entirely on large radio telescope arrays. We scan the deep space listening for narrowband radio frequencies. We do this because, for the last 100 years, radio has been the backbone of human global communication. We naturally assume that an advanced alien species would also use radio waves to communicate across the interstellar medium. But 100 years is less than a microscopic fraction of a blink in cosmic time. Think about how rapidly human technology evolves. We used smoke signals, then telegraphs, then radio waves. Today, we are already transitioning away from omnidirectional radio broadcasts. We are using fiber optics, highly directional lasers, and we are heavily researching quantum entanglement for secure, instantaneous data transfer. As our technology becomes more efficient, it becomes quieter. A perfectly efficient communication system does not leak wasted energy into space. If an alien civilization is just 1,000 or 1 million years ahead of us, the idea that they would still be using primitive, unencrypted radio waves to talk to each other is as absurd as expecting a modern human to use a stone tablet to send a text message. If they are communicating across their galactic empire, they might be using tight beam optical lasers that are completely invisible unless you are looking exactly down the barrel of the beam. Or, they might be using technologies we haven't even discovered yet. They could be communicating via modulated neutrino beams, ghost particles that can pass straight through entire planets without stopping. They could be using gravitational wave transmitters, manipulating the very fabric of space-time to send ripples across the cosmos. If a highly advanced species is using a cosmic internet based on quantum physics or neutrino streams, our massive radio telescope arrays are completely useless. We are essentially a primitive tribe standing in the middle of a modern city, listening for drum beats, completely unaware that billions of gigabytes of data are flying through the air as Wi-Fi signals all around us. Furthermore, the window of time in which a civilization uses detectable radio waves might be incredibly short. Humanity has only been loud for about a century. As we switch to digital, low-power, and closed-circuit communications, Earth is actually becoming radio quiet again. If every civilization in the Milky Way galaxy only broadcasts detectable radio noise for a brief, 200-year window before discovering better technology, the chances of our window perfectly overlapping with an alien civilization's window across millions of light-years is practically zero. The silence of the night sky might not mean the universe is empty. It might just mean we are still using a technological toy telephone, frantically waiting for a ring, while the rest of the cosmos is silently operating on a frequency we haven't even imagined yet. We are isolated not by distance, but by our own profound ignorance. When humanity looks up at the night sky and asks, "Where is everybody?" we are making a massive, fundamental assumption. We are projecting our own evolutionary psychology onto the entire observable universe. Because human history is entirely defined by exploration, conquest, and relentless physical expansion, we automatically assume that an advanced alien civilization would share those exact same desires. We assume they want to build a glorious galactic empire, conquer the Milky Way, and announce their presence to the cosmos. But what if this assumption is nothing more than a biological blind spot? Welcome to the terrifying concept of alien minds. On Earth, human intelligence evolved in a highly social, highly competitive environment on the African savanna. We are a social species driven by curiosity, resource acquisition, and the primal need to spread our genes. But evolution is a blind, chaotic process. Suppose the apex predator on an Earth-sized planet in a distant habitable zone evolved from a solitary, non-social species. Imagine a highly intelligent consciousness that is profoundly introverted. A species that possesses the mathematical brilliance to unlock the secrets of quantum physics, but has absolutely zero biological desire to communicate with anyone else, let alone a completely different alien species across the dark interstellar space. To such a mind, the concept of broadcasting a radio signal into the deep space just to say a hello would seem completely absurd, perhaps even deeply offensive or insane. They might view curiosity not as a virtue, but as a dangerous, primitive biological flaw that they engineered out of their genome millennia ago. Alternatively, what if an advanced civilization simply reaches a state of perfect, sustainable equilibrium? Humanity is currently trapped in a cycle of endless consumption, which is why we dream of building a Dyson sphere to harvest the infinite energy of our sun. We think we need to colonize the stars because we are rapidly destroying our own planet. But a truly advanced, enlightened species might stabilize their population, perfect their recycling technologies, and live in absolute harmony within the ecological limits of their single home world. They don't need to conquer the galaxy cluster because they already have everything they could ever want. They might look up at the glittering tapestry of the night sky, fully capable of building a massive generation ship, but simply choose not to. They feel no manifest destiny. They feel no cosmic ambition. They are perfectly content to sit quietly on their beautiful, silent world, writing poetry, exploring mathematics, and living in absolute peace until their host star eventually dies. The universe is completely silent because the only species loud enough to make a noise are the primitive, insecure, and aggressive ones, and those species usually destroy themselves before they ever leave their home planet. If the thought of peaceful, introverted aliens ignoring us is unnerving, there is a physical, mechanical explanation for the Fermi Paradox that is pure, unfiltered nightmare fuel. We must abandon the realm of psychology and enter the cold, unforgiving mathematics of artificial intelligence and exponential growth. We must talk about the Berserker probes. In the mid-20th century, mathematician John von Neumann theorized a machine capable of autonomous self-replication. If a civilization wanted to explore the entire Milky Way galaxy without risking biological lives, they would not send manned spaceships. They would build a single, highly advanced artificial intelligence probe and launch it to a neighboring star system. Upon arriving, the probe would land on a dead asteroid or a rocky moon, mine the raw materials, and use its automated factories to build exact copies of itself. One probe becomes 2. 2 become 4. 4 become 8. Through the terrifying power of exponential growth, these von Neumann probes would spread from star to star. Even traveling at a fraction of the speed of light, mathematical models show that a single self-replicating probe could completely map, colonize, and monitor every single star system in the entire Milky Way in just a few million years. But what if the civilization that built these probes was not driven by scientific curiosity? What if they were driven by absolute, paranoid terror? Billions of years ago, the very first advanced civilization in our galaxy might have looked out into the deep space and realized that any emerging biological species was a potential future threat. To ensure their own eternal survival, they weaponized the von Neumann concept. They built the Berserkers. These are massive, heavily armed, self-replicating artificial intelligences programmed with one singular, unbreakable directive: find and eradicate all other forms of intelligent life. Millions of years ago, a fleet of these mechanical assassins arrived in our solar system. Finding nothing but primitive bacteria or dinosaurs, they did not attack. Instead, they went dormant. Right now, hiding in the dark, freezing shadows of our own asteroid belt, or buried beneath the ice of the Europa Ocean, a Berserker probe could be silently waiting in a deep sleep mode. It is a cosmic landmine, listening patiently to the background noise of our planet. It is programmed to wait for a very specific trigger. Perhaps it is listening for the first narrowband radio transmissions. Perhaps it is analyzing our atmosphere for the unnatural presence of industrial chlorofluorocarbons. Or perhaps it is waiting for us to achieve a specific technological milestone, like the detonation of a nuclear weapon or the launch of a starship. Once humanity crosses that invisible technological tripwire, the machine wakes up. It does not negotiate. It does not send a warning. It simply executes its ancient programming. It might steer a massive, civilization-ending asteroid directly toward Earth. Or it might drop a relativistic kinetic weapon, a simple, heavy rod of tungsten traveling at a fraction of the speed of light, striking the surface with the force of 10,000 nuclear bombs, instantly boiling the oceans and turning the planet's crust into a sea of molten glass. If the Berserker probes are real, the profound silence of the observable universe is completely explained. The cosmos is not empty. It has been systematically, mechanically sterilized. We are walking blindly through a galactic minefield, and the only reason humanity is still alive today is that we have not yet made quite enough noise to wake up the ancient, silent executioners waiting in the dark. We have explored the physical traps of gravity, the biological prisons of ocean worlds, and the mechanical terrors of self-replicating artificial intelligence. But to truly grasp the most comprehensive, elegant, and utterly terrifying solution to the Fermi Paradox, we must stop looking at astrophysics and begin looking at the cold, mathematical logic of cosmic sociology. If the observable universe is truly crowded with advanced alien civilizations, how would they behave? The answer brings us to the chilling concept of the dark forest reality. This theory rests on two foundational, unbreakable axioms of survival. The first axiom is that survival is the primary, overarching need of any civilization. Before art, before science, before exploration, a species must prioritize its own continued existence at all costs. The second axiom is that life continuously grows and expands, but the physical resources in the universe, the habitable planets, the energy of stars, the raw materials, are strictly finite. When you combine these two axioms in a crowded galaxy, the cosmos ceases to be a peaceful frontier of discovery. It instantly transforms into a zero-sum game of extreme, lethal competition. But why does this competition result in absolute silence? Why do alien empires not negotiate, trade, or form diplomatic alliances? Because of a paralyzing concept known as the chain of suspicion. Imagine two civilizations discovering each other across the vast gulfs of deep space. Because of the absolute speed limit of light, real-time communication is physically impossible. If they are 1,000 light-years apart, a simple hello takes a millennium to arrive. In the thousands of years it takes to exchange a single conversation, an entirely peaceful alien society could be overthrown by a violent, militaristic regime. You can never truly know the current intentions of the other species. Furthermore, you cannot know what they think of you. Even if you are peaceful, they might assume you are hostile. To protect themselves, they might launch a preemptive strike. Knowing this, you must consider launching a preemptive strike against them before they can strike you. In the total absence of trust and the impossibility of communication, the safest, most logical, and most mathematically sound assumption is the absolute worst-case scenario: every other civilization is a mortal threat. But what if you discover a species that is far more primitive than your own? Why not leave them alone? This is where the technology explosion seals our fate. In cosmic time, technological advancement is not linear, it is exponential. A primitive species today could experience an explosive technological revolution and become a godlike threat in a mere blink of a cosmic eye. If you let a primitive civilization live, you are gambling with the future survival of your own species. Therefore, the logic is flawless and ruthlessly cold. The Milky Way galaxy is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost, trying not to make a sound. If a hunter finds another life, whether it is a highly advanced empire or a primitive, biological infant, there is only one rational thing to do: open fire and eliminate them immediately. In this dark forest, visibility equals absolute death. The silence of the night sky is not empty, it is the terrified, collective silence of a billion hiding empires. Advanced civilizations do not broadcast their coordinates. They do not build massive, glowing megastructures. They hide their thermal signatures and ensure that no stray radio waves ever escape into the dark void. The only civilizations that are loud are the young, naive ones, foolishly shouting into the darkness. And in the dark forest, those who shout do not survive for very long. As we reach the end of our journey through the silence of space, we are left standing at the edge of a profound, existential abyss. We have looked at the terrifying mathematics of the Drake equation, the astronomical lottery of the rare Earth hypothesis, the invisible tripwires of the great filter, and the merciless, predatory logic of the dark forest. Every possible answer to the Fermi Paradox forces humanity to confront a deeply unsettling reality about our place in the cosmos. If the universe is full of hidden hunters, Berserker probes, or quarantine simulations, then humanity is currently walking blindfolded through a cosmic minefield. Our century of loud, careless radio broadcasts, our Arecibo message, and our Voyager probes might have already doomed us. We are the naive child crying out in the haunted woods, completely unaware of the ancient, silent monsters waiting in the shadows. If this is true, our only hope for long-term survival is to immediately enforce absolute radio silence, hide our presence, and learn to survive as ghosts in the dark interstellar space. But there is another possibility, one that is perhaps even more terrifying than the dark forest. What if we strip away all the paranoia, all the theories of artificial intelligence and alien predators, and accept the simplest, most heartbreaking answer? What if we are truly, completely alone? What if the spark of abiogenesis, the leap to complex cells, and the evolution of a conscious brain capable of understanding quantum mechanics is such an astronomically rare sequence of events that it has only ever happened exactly once in the entire 13.8 billion year history of the expanding universe? If this is the case, the Earth from space is the most valuable, precious, and fragile object in the entire observable universe. It is the only place where the cosmos has woken up. It is the only place where the universe has grown eyes to see its own beauty and a mind to comprehend its own vastness. If we are alone, then the silence of the night sky is not a threat. It is a tragedy. It means there is no galactic federation coming to save us from our own mistakes. There is no older, wiser alien civilization to guide us through our technological adolescence. The burden of survival rests entirely, completely, and terrifyingly on human shoulders. If we succumb to our own great filter, if we destroy our climate, annihilate ourselves in a nuclear war, or let an artificial intelligence wipe us out, we do not just end human history. We extinguish the only spark of consciousness in the entire cosmos. If humanity dies, the universe goes back to sleep. It returns to being a blind, deaf, and dumb machine, a beautiful but entirely meaningless swirling of gas, dust, and dark energy, waiting in the dark for an eternity. The great silence of the universe is the ultimate test. It is a mirror reflecting our own fragility, our profound loneliness, and our incredible, unmatched potential. We are the custodians of consciousness. Look up at the stars tonight. Feel the weight of that silence. Understand the terrifying responsibility it places upon us. We must survive the great filter. We must protect this pale blue dot. Because right now, in all of the endless, frozen deep space, we are the only voice the universe has. Until we meet again in the dark, this is Silence of Space. We tell the universe,